We're going to explore regular expressions. Regular expressions are used to search for specific patterns in text. They can also be used to represent regular languages. So what we mean by that is different sets of strings. A regular expression is a shorthand way of representing a set. Now, meta characters, they help us to produce this shorthand. So let's have a look at a few of these. Not going to show you all of them, but the ones that are really and most useful perhaps. So the first one here is the meta character, is the star. And what this means is that 0 or more occurrences of the character in front. So in this example here, it would mean 0 or more occurrences of A. The next one is plus. This one means 1 or more occurrences, and if we have A followed by the meta character plus, what this would mean is you would have 1 or more occurrences of A. The next meta character looks like a question mark, and what this means is that you have 0 or 1 of the preceding character. So in the example here, you'd have 0 or 1 A's. The pipe here, meta characters, the vertical line here, what that means is an alternative. So in this example, you could either have the character A or the character B. And then finally, when we have parentheses like this, what this means is a group expression. Let's now have a look at an example of a set. So we have a set here. It's an infinite set indicated by the ellipses at the end here. And we can use the following regular expression to represent this set. So what we're saying is we have an A to begin with, followed by 1 or more, 0 or 1A, followed by any number of B's. So we can have 0 or more B's. So this would allow us to represent all the values within this set here. Let's have a look at some worked examples of the sorts of questions that you might get asked. So if you have the regular expression A star, B star, first of all, what does that description look like in words? So we can say that we have 0 or more A's followed by 0 or more B's. This can mean, if we have 0 A's and 0 B's, this can mean we can actually have an empty string, which is perfectly legitimate within regular expressions. You can have empty strings. So valid strings here, including an empty string, you'd have these ones here. You can see the list there. So you can have A on its own, B on its own, A, B, any number of A's, followed by any number of B's essentially is what you're allowed to have. So it would be, again, this would be an infinite series in this situation, as indicated again by the ellipses. In the second example here, we have this regular expression here. So we have an alternate there. You can see that we have a group expression. We have again the star to indicate 0 or more repetitions of the preceding character. The description of this would be that we have 0 or 1 followed by 0 or more zeros followed by a 1. So this would always have to end with a 1. So again, some valid strings here. And again, this is an infinite series. Now it could be you're presented with the set and you have to come up with a regular expression for the set. So it's this same problem, but the other way around. Again, we need to describe the set. So if we're to describe this set, we describe it as a single one followed by 1 or more zeros, given the values of the sets we have here. And the regular expression for that would look like this. Well, there'd be two alternates here. You could have 1, 0 followed by the plus meta character, or you could have a group expression around the 1 and the 0, and then you can have 0 or more repetitions of 0. Another worked example here, we have the following set here with just two items in it. So we have two elements in this set. So it's a very small set, and in reality probably wouldn't want to go to the effort of creating a regular expression for this, but nevertheless we'll proceed anyway. So description of this would be A or B followed by AB. That's what our description would come up with. So for our expression here, we'd have A or B as an alternative and then followed by AB. A finite state machine can also be used to represent a regular expression. So the finite state machine for this expression here, as you can see, which means that we have one or more A followed by a single B, is given here. So this is our finite state machine for that. And what we're saying is that if we're starting at state 0, so S0, we have to have, it has to start with a single A, our string. We can then have as many A's as we wish. So you can see at state 1, we've got as many reoccurrences of A as we would like to have here. And then our string has to end with a B to get to our accept state, state 2, S2 here. For good measure, we're going to look at a second example of a finite state machine. So in this situation, we have a regular expression that allows us to have 0 or 1A followed by 1 or more B. So you have a range of valid strings there. It's an infinite series. And this is our corresponding finite state machine. So again, looking at this, we're starting at state 0 here. And we can either have an A, so follow the route to state 1. So it's a choice whether we have an A or not at the beginning of our string. So we could either go to state 1 or we could go directly to state 2. Now we have to have clearly at least one B. So whether it's state 0 or at state 1, we have to have a B. And then once we're at state 2, we're in the accept state, and we can have as many additional B's as we wish at that stage. So we've now explored regular expressions, regular languages, and how finite state machines relate to regular expressions and languages in this presentation.